Наталья Ивановна, уважаемые коллеги, добрый день. Хочу
Dear
также
colleagues, good afternoon. I would like to thank you for the opportunity to participate in the symposium. I'll be talking about possibilities for diagnosing the initial stage of glaucoma using an artificial neural network model under the auspices of Professor Koryadov. Well, here is the disclosure of the conflict of interest. I'd like to quote Ivan Petrovich Pavlov, who many years ago said the causes of the disease creep in and begin to act in the body before the patient becomes the object of the doctor's attention. That means early diagnosis of the disease in order to start proper therapy. This problem is very relevant because as for open closure glaucoma, is of great importance. Right now, the problem of predicting a borderline stain remains a priority for global glaucomatology. One of the main risk factors for the development and progression of the disease is age, people over 40 years of age, to be more precise. So a mandatory annual glaucoma screening includes sternometry in people over 40 years of age. And another perspective aspect is the use of convolutional neural networks, CNN, which are widely and effectively used in other areas of ophthalmology and medicine. Well, as for advantages and disadvantages of existing decision-making methods, we encounter specific difficulties, such as, well, issues related to routine clinical practice, the development of algorithms. Well, however, neuron networks have the high level of specificity and sensitivity. They are devoid of some of the disadvantages shown on this slide. Application of artificial intelligence and deep learning in the diagnosis of glaucoma and current models and algorithms for treatment allows us to give answers to many questions. We can use multimodal algorithms, but there are difficulties here as well. First, the difficulty of perfectly matching changes in structure and function. Secondly, training models need a sufficient amount of identical paired data. And thirdly, large intraspecific differences, as you can see it here. Well, as our target of research, it boils down to evaluating the effectiveness of glaucoma screening and monitoring using AI. Here you can see the material and research methods and our study design. It's a retrospective analysis of the HRTOCT database ophthalmology department, 8,600 eyes. Well, also, we analyzed the development and training of a neural network for diagnosing glaucoma. We assessed the effectiveness of a neural network, adjusting such a network. These data were used to train a neural network, and in order to test the work, we used also the sub-modality. We used the prospective study, as you can see here, 199 eyes, and we used the screening as a new diagnostic method. Our neural network consisted of several layers, and our goal was to tell the norm from pathology. And first of all, the neural network consists of 5 convolutional layers, such as filters of size, alternating with subsampling operations after the first, second, and fifth convolution layers. And according to first stage, the age of patients was taken into consideration, and the age of patients with stage 0 was calculated based on data presented in publications from 2004 to 20, from which the average duration of each stage of glaucoma was initially calculated in order to identify the age characteristics of risk groups requiring screening for glaucoma. The established age at stage 0 was 54 years. At stage 2, we assessed the sensitivity and specificity of the developed ANN. So we used the sensitivity of classification when divided by stages, and you can see here we had the high indicators for late stage glaucoma, but for stage 1, the indicators were quite low. That's one of the major problems. At stage 3, well, we used the healthy groups of patients, 36 men, 8 women in the first group, age 63, as you can see it here, 54 patients altogether. Group 2, 65 eyes, 37 patients, ages from 61 to 66, and we used different methods, including OCT and others, and then we applied artificial intelligence to analyze the situation. Also, evaluation of the effectiveness of the developed ANN, comparison of groups of the first and second prospective studies. And you can see the comparison. First, the prospective study and the second prospective study on the right, 100 patients on the left, 65 on the right, and you can see the selected subgroups. So according to the data obtained, we also selected those eyes with the possible development of glaucoma. And on the basis of the examination, we also identified patients with glaucomatic changes. Here you can see the results. First prospective study, examples of optic discs selected by artificial neural network, ANN, and you can see here that these are the optic discs which are not having any changes such as glaucoma. Here you can see also another analysis, the second prospective study, the size of the disc, well, etc. And according to our analysis, we established statistically significant differences in the parameters of the patient's eyes on the results of two-phased prospective studies. So you can see the second prospective study, the disc area of the optic disc sectors in relation to the assessment of the RNFL, also superior temporal sector, nasal sector, etc. Well, when we assessed the performance of the developed ANN, artificial neural network, you can see the sensitivity and specificity, which are lower as compared to the trained group, as you can see it here. So you can see the comparison between training and the group 1 and 2. Nevertheless, we analyzed the patients before the onset of the initial stage of glaucoma. And of course, well, there were also lots of false positive cases, which requires additional attention. So that is why we hope that we'll be able to improve ANL at the training stage so that we could increase its specificity, and it will be used in the future to make the proper diagnosis. Well, here you can see another results, evaluation of the performance of the developed artificial neural network. When we conducted this additional analysis, we could do the analysis of image quality, refraction, and transparency of optical media. Thus, we can obtain good quality images and proper interpret those images by the neural network. So you can see the stages of the study and the relationships between the selected groups. We came up with our own algorithm for screening and monitoring of POAG using an artificial neural network, such as tonometry, then photo registration of the posterior segment of the eye. Well, if we use A and N, we can make the diagnosis, and also if the tonometry is positive, we can carry out a complex of examinations for glaucoma using standard methods, while also we can use further annual observation for monitoring depending on the situation. Here are the main prospects for the development of methods of diagnosis and monitoring of glaucoma at the present stage. We have developed the algorithm. Methods are at the top, then we use diagnostics and monitoring depending on the situation, and again, well, monitoring and modification of the approach depending on the situation. And in conclusion, I'd like to say that to improve existing methodologies in future work, it is necessary to use more reliable classification signs of diseases. Perhaps AI will contribute to this, optimize data input for analyzing the results of neural networks, and also improve methods for assimilating the received information. AI has not yet fully appreciated potential in the field of screening, diagnosis, monitoring, and classification of POAG, both through automated processing of large data sets and through early detection of the disease. AI technologies promise to fundamentally change research aimed at understanding the development, progression, and treatment of glaucoma by identifying new risk factors and assessing the importance of existing ones. The use of IT technologies in glaucomatology is a modern, effective, and promising diagnostic method. Thank you very much for your attention.